Hello students, let us start our new chapter, the current electricity. Let us see the first part of the current electricity, in which we will discuss about the electric current, conventional current, drift velocity of electrons and current density, Ohm's law, resistance, resistivity, conductance and conductivity. Also, temperature dependence of resistance, color codes for carbon resistor. This topic was removed from the syllabus, but we discuss this because this is important for the lab. Now, for further, we will discuss more about the series and parallel combination of the resistor, EMF and potential difference of a cell, internal resistance of a cell, and the series and parallel combination of the cell. This is the first part of the current electricity. Now let us start our topic, the electric current. We know that the electric current is defined as the charge flowing through any section of the conductor in 1 second. It can be represented by symbol capital I equal to Q by T if the rate of flow of charge is steady, but if the rate of flow of charge varies with time, then I can be expressed as dQ by dt. Different types of current. First, a steady current which does not vary with time, and the current which varying with the time. Suppose that there are many types of current which are varying its amplitude with respect to time. They are also expressed by the graph. Let us see the graph. Then you will find that the line is represented by blue color, A. Okay, this A line from here to here, this line expresses the steady current which does not vary its magnitude with respect to time, and the line which varies its amplitude with respect to time continuously, the graph expresses by the line B. Okay, this B line represents the varying current in which magnitude of the current increases with a constant rate with respect to time. Okay, and the graph C also indicates the magnitude of the current increases with respect to time, but the graph C is not varies the magnitude of current with a constant rate with respect to time. And the fourth graph, that is represented by red color and the symbol D. So such type of current represents the alternating current whose magnitude varies continuously and direction changes periodically. It means in first period this is positive one, and in the other period this is the negative one. Okay, now come to the next topic, that is conventional current. What is conventional current? Conventional current is the current whose direction is along the direction of the motion of positive charge under the action of electric field. Conventional current, due to motion of electrons, is in the direction opposite to that of motion of electrons. Okay, in the figure it is clear that what is conventional current. Conventional current is the current whose direction is along the direction of motion of positive charge. It means in which direction positive charges moves, in that direction conventional currents can be taken. Okay, that can be also taken in the direction of the electric field. Okay, now the next topic, what is the drift velocity and what is the drift current? Drift velocity is defined as the velocity with which the free electrons get drifted towards the positive terminal under the effect of the applied electric field. I repeat, drift velocity is defined as the velocity with which the free electrons get drifted towards the positive terminal under the effect of applied electric field. It can be expressed as vector Vd. This is a vector quantity. Vector Vd can be expressed as the vector A multiplied by T. Vd equal to if we put the value of acceleration acting on any electron moving inside the conductor in the presence of electric field whose mass is m is E upon m, the magnitude of the charge multiplied by the field divided by m. This is the value of the acceleration, because we know that the charge on the electron is negative, so the direction of the acceleration acting on the electron will opposite to the direction of electric field, so here a negative sign arises. So the formula for the drift velocity is minus of E upon m whole into t, that is tau. So if we put all these values, then we get a formula for the conventional current, that is I equal to NEA into VD. Current is, from here we can see that current is directly proportional to the drift velocity. Current is directly proportional to drift velocity. VD, that is drift velocity, is the acceleration, tau is the relaxation time, E is the electric field, E is the electronic charge, m is the mass of electron, n is the number density of electrons, it means the electron present per unit volume, L is the length of the conductor, and A is the area of cross section. Now come to the next topic, current density. Current density at a point within a conductor is the current through a unit area of the conductor around that point, provided the area is perpendicular to the direction of flow of current at that point. So it can be represented by J equal to I by A, that is equal to NEVD. In vector form it can be written as I equal to J dot A, because vector J is a vector quantity, it means current density is a vector quantity, area is also a vector quantity that can be represented by vector A, and the dot product of two vectors can be expressed as a scalar quantity, that is electric current. So I equal to vector J dot vector A. Now come to the most popular law, that is known as Ohm's law. What is Ohm's law? The electric current flowing through a conductor is directly proportional to the potential difference across the two ends of the conductor when physical conditions such as temperature, mechanical strain, etc. remain the same or constant. So I proportional to V or V proportional to I. If we remove the proportionality, then we get V equal to Ri, where R is the proportionality constant, that is known as the resistance of the conductor in which current is flowing or across which the potential is applied. If we plot a graph between I and V, then we find out this is a straight line, and starting from the 0, it means the ratio of the voltage to the current is constant, and that constant can be expressed as the resistance of the conductor. Okay, now let us define what is the resistance of a conductor. The resistance of conductor is the opposition offered by the conductor to the flow of electric current through resistance in terms of physical features of the conductor. We know that I can be expressed as NEAVD, and the magnitude of the VD can be expressed as E multiplied by the electric field divided by M. Now this electric field can be expressed as the potential across the conductor divided by the length of the conductor, that is V divided by L. So this E can be expressed as V by L. So I becomes NE square A tau upon M into V by L. So if we replace the I and L either side, then from here we get V upon I is equal to M L divided by NE square A into tau. So from the definition of the resistance, according to the Ohm's law, V upon I, that can be expressed as R, that can be expressed as M upon NE square L by A. This is L, not I. Okay, R equal to M upon NE square tau dot L by A. So if we are seeing in this formula, then we get that the value of M, that is mass of the electron, the N, that is number of charge density, E, that is charge present on one electron, tau, that is relaxation time, that is the time, average time for the in between the collision of electrons, are getting the time from relieving the one atom to reaching at the another atom. So all these are the constant. So if we replace the term m upon n e square tau by a symbol rho, that is resistivity of the material, so we can easily find out that R equal to rho L by A. It means R equal to rho L by A, where rho equal to m upon n e square tau. It is known as resistivity or specific resistance. Resistance is directly proportional to length. From here we are saying that R is directly proportional to L and inversely proportional to A. Okay, it means resistance is directly proportional to the length of the conductor and inversely proportional to the cross sectional area of the conductor and depends on nature of material, that is rho. So here resistivity depends upon nature of the material and not on the geometrical dimension of the conductor. It means the value of rho does not depend upon the L or A, because from here we are saying that the value of rho is m upon n e square tau. It means the value of rho does not depend upon the L and A, that is the physical dimension of the conductor. Okay, the relation between VD, rho, I, E, J and V. From here we know that rho equal to E by J. So this can be expressed as E upon N E VD. Since we know that J equal to I by A, so I, that is equal to NEA VD, so A and A will be cancel each other and the value of J is coming from NEA VD. So E by J is E by J, that is equal to rho, that will also equal to E by NE VD. Now VD equal to E upon NE rho. This is another formula which relates the VD, E, N, E and rho, and also VD equal to V upon NE rho L. So since equal to V upon L. Okay, this is the formula for the potential gradient, that is in terms of the electric field. Now when temperature increases, VD decreases and rho increases. So when I increases, VD decreases. This is a simple concept which relates the dependency of the temperature and also the dependency of the VD on current. Okay, conductance and conductivity. We know that conductance is the reciprocal of the resistance. Its SI unit is mho, MHO, mho. Conductivity is the reciprocal of the resistivity. Its SI unit is mho per meter. And temperature dependence of resistance. We know that R equal to m upon n e square tau dot L by A. From here we know that when temperature increases, the number of collisions increases due to more internal energy and relaxation time decreases, therefore resistance increases. It means when R increases, then the resistance is also increases. Okay, now temperature coefficient of resistance. Suppose that if the temperature coefficient of the conductor is alpha, then alpha can be defined as the resistance at temperature T minus resistance at temperature 0 divided by resistance at 0 multiplied by the temperature difference. So alpha also can be expressed as R2 minus R1 divided by R1 T2 minus R2 T1. Okay, where R2 is less than R1, then alpha is negative. Agar if we take R1 is greater than R2, then alpha becomes positive, where R0 is the resistance at 0 degree centigrade, RT is the resistance at T degree centigrade, R1 is the resistance at T1 degree centigrade, and R2 is the resistance at T2 degree centigrade. This is all about the today's discussion, that is what is the conductance, conductivity, resistance, resistivity, conventional current, depth, velocity, Ohm's law, current density, etc. Okay, thank you.